Hello, folks. So I wanted to talk about the homework question that we did talk about it a little bit in class, at least some of the classes, but I don't think every class did, and I just wanted to take a little bit more time here to go a little more in depth with it in case the explanation in class maybe went too fast or was not super clear. Okay, so here's the question. Or the task rather, we want to create an equation of a function. So there's a polynomial function, we'll call it p of x, and it's got four requirements. Okay, so our requirements are one, that it is fourth degree. The second one is that p of 1 is 640. Again, that just means that it contains the point 1 comma 640. The only real roots we have are at -4 and 5. I should have said this. There are also not supposed to be any complex roots. So there are no complex roots. That was intended in the problem. Excuse me. And we also know that p of 10 is negative, so it's less than 0. Okay. The first thing what I'm going to do when I see something like this is to draw a picture. Right, so I think that's been pretty consistent with what I've been kind of suggesting you do in class. And again, this is just a rough sketch. So my only real roots are at -4 and 5. So right there, and let's say right there. I know I'm using graph paper, and I have graph paper. I'm not using it. So you know what? Let's just pretend I don't have graph paper. Okay, what else do I know? Well, I also know that p of 1 is 640. So when I graph, say 1 is right here, then I'm way up here at 640. 1, 640. Okay, so at this point, oh wait, sorry, hang on. Okay, I just still checked that I was recording correctly, which I think I am. Okay, so that's that. I've checked off this part. I've checked off this part, at least in my drawing. I know that p of 10 is less than 0. So remember, because this is a polynomial function, it's going to look something like this, right? And there's some squiggles. What I also know is that because my only real roots are at 4 and -5, once it goes down, either down here, it's not going to come back up, or vice versa. If it goes up through here, it won't go back down because there's no other x-intercept. So if p of 10, which is let's say way over here, is negative, I know the graph is going to end up way down here. So I can kind of already sketch part of the graph, and it's going to look something like that. Okay, so that takes care of that part. And the last part is we need to make sure that this thing is fourth degree. Okay, so if there are only two real roots, then, well, from the factor theorem, we can kind of work this backwards already and start building our function. So right now, well, I guess not y, but p of x is equal to x minus 1, sorry, x minus 1, x minus -4, and x minus 5. So again, this is really just x plus 4. Okay, but if I just left it there, well, there's a couple things wrong with this. First off, you can tell that if you plug in 1, you're not going to get 640 into this function. But also, it's not even fourth degree. So I know that because if I was to multiply this out, right, this is just 1 and 1. I only have two linear factors. And so when I multiply it all out, I will get x squared plus etc., etc. So I already know that this is not quite done. How do I fix this? So there's a couple ways to make this fourth degree. Essentially, I just need to make either one of the roots a triple root or both of the roots double roots. So I could either do this, 1 and 3. I could do squared and squared, or I could do cubed on the first one and then raise the second one to the first. Okay, I want to actually draw each of these just to show that these can't actually all happen. So let's pretend that this one is in green, and then I'll draw it. So again, we know that this graph is going to end up negative, like so, because again of this part. Okay, so if I have it like so, so at x equals 5, x equals 5 is a triple root, right? So it's going to look like a x cubed graph or a cubic graph. So it's going to go down like this and have this little squiggly sign. There's nothing about the function that says what has to happen here, so that still checks out. It will eventually go up to 640, right? So this checks out, right? It won't turn around or anything like that. It will eventually turn around. Sorry, it will eventually turn around because it has to come back down to -4, and it'll just keep going like that. So that's one possibility. The other possibility is I'll do this one in red. If I cube the first one, and then the x minus 5 term, or factor, excuse me, is just raised to the first. So if I do that, we'll have a similar drawing where, again, we are starting off negative. I'm going to just alter the shape slightly so we can see all three of these. Excuse me. And so it go like this. Again, because this one is just x to the first, it will just go straight through right here. And then it'll go like so. And then at -4, that's when we'll see that x cubed like shape. But both of these graphs are possible, again, given the situation, or given the requirements of our function now. Now if I draw this one, and let's try purple here. For this one, x squared and squared, you might have noticed something at this point, where if I have, again, it has to end negative down here. If it's x minus 5 squared, excuse me, it's going to look like a quadratic function, or like a parabola, like right there. And so because it's even degree, this is going to happen, and it has to bounce, again, quote unquote, bounce off the x-axis and come back down. And then it would come back up here, because again, it has to hit -4 at some point, and then come back down again, because again, that x plus 4, that is also a second degree, a quadratic factor, or a linear factor that is repeated twice. Okay, slight problem with this purple one though is that because of this, the way that it's going down in between -4 and 5, it's negative between -4 and 5. It can't be up here, and so that can't actually happen at all, given the requirements of this problem. So this is not possible. You are stuck with either of these. Okay, so at this point, you actually can do either of them. So let's pretend we're going to stick with the green one, and then I'll talk about this green one, and then I'm going to leave it to you to fix the red one. But if I just check with the green one, you'll see that, again, on its own, it's not done, right? So let me erase the red one here. The green one itself is not done, and we can check, well, by either plugging in 1, and you'll see that you don't get 640. Sorry, yeah, you'll plug in 1, you don't get 640. And also, if you were to multiply this out, we also know that this is going to be a positive 1, x to the 4th plus etc. And, well, if it's positive x to the 4th, the graph should end up here, which is obviously not what's happening. And I want to take the time to explain why this happens. I think I might have done this in a previous video. Again, I'm recording this like 2-3 years after I record all the other ones. But let's take a look at an example on Desmos. So the example I want to look at is, what if I had a function that had roots at, let's say, what did I say before? 2 and -1. Sorry, I'm backwards. -2 and +1. Right? Let's just pretend that I'm looking for a function that has those x-intercepts. Okie dokie. So at -2 and +1, you can see that we have x-intercepts right here. And of course, the function that would give me that is that, again, based off the factor theorem. But this is not the only function that does that, right? Because I could have something that maybe looks like this, right? That has the same x-intercepts, but is now maybe upside down, and it's also a lot skinnier. Why is this? Well, remember that when we're factoring, there's always the possibility of being able to factor out like a common factor. So instead of saying x plus 1, instead of maybe x plus 1, I said 2x minus 2. That would still give you an x-intercept at 1, but you could factor out that common factor of 2. And that affects the graph. Again, we call this thing a stretch factor. Different people have different names for it, but I call it a stretch factor. So again, depending on what a is, it doesn't, notice that no matter what a is, it doesn't change the x-intercepts, because zero product property, a is never actually 0. Excuse me. Well, I guess in theory it could be 0, but it's not interesting if it's 0. With zero product property, the only times you're going to get x-intercepts are when the factors, the things in parentheses, are 0. A being a constant out front, which is presumably not 0, will never happen. And so there's always a possibility of this a value. Now, it might just be 1 and then you're done, but you should always double check what it is. So if we go back here, I need to make sure that this a value appropriately solves this. Okay, so let's do that. So let's pretend I don't know what a is, which, well, not pretend, I actually don't know what a is, right? But what I do know that p of 1, which is a, and then that just means you plug in 1, so I get 1 plus 4 to the first, 1 minus 5 cubed, that must come out to 640, right? And if you solve this, you will get the a value, which is, stand by, I believe the a value is -2. And so our function, p of x, is -2, x plus 4, x minus 5 cubed. And that will get you where you need to go. Okay, so I hope that hopefully that helped. Again, remember, that is not the only way to do this problem given the restrictions. So you could have also done it this way, x plus 4 cubed and then x minus 5 to the first. Again, you'll do the same thing and you'll just get a different a value though. So let's actually just double check this. So let's plop this into Desmos. So I'm plugging in -2, x plus 4, x minus 5 to the third. We're going to have to do some zooming out, but of course you can see, so far anyway, oops, we got x-intercepts at -4 and +5, and it ends in the negative direction, which is what it should happen. Let's change our y-axis from -10 to 700, and you can see right here, hopefully you can see it, right here at, I saw it for a second, at 1 we do get 640 as an output. So hopefully that helps. I'll see you in the next video whenever that is.